Alright guys, we are on lesson 4, identifying proportional and non-proportional relationships in tables, and this is page 31 of your workbook. And this is an example of, this is a very common type of proportional example. Which team will win the race? So you have decided to walk in a long distance race. There are two teams that you can join. Team A walks at a constant rate. So that's very important. This one is constant rate. This one is going to be proportional then. Team B walks 4 miles the first hour and then 2 miles after that. So 4 miles for the first hour and then 2 miles each hour after that. Okay? So we're creating a table for each team showing the distance that would be walked for times of 1, 2, 3, 4, 5, and 6 hours. So 1, 2, 3, 4, 5, 6. Your x value is hours and your y value, again, is distance in miles. And this is what you're figuring out. So for team A walks at a constant rate of 2.5 miles per hour, 2.5 miles for the first hour. And then every hour is 2.5 miles, so you're multiplying this by a constant of 2.5 to get y. So we have 2 times 2.5, which is 5. 3 times 2.5, right? You could write that there if you need to, is 7.5. 4 times 2.5 is 10. 5 times 2.5 is 12.5. And then 6 is 15. Okay, for this one we're doing the same times 1, 2, 3, 4, 5, and 6. And then the first hour, team B walks 4 miles, and then 2 miles after every hour. So 4, then plus, so we have that 4 plus 2, which is 6. And then we have that 6 plus 2, which is 8. 8 plus 2 is 10, 12, 14, so you're adding to every hour for team B. Okay, so for which team is distance proportional to time? Obviously, that's the first one we created, team A, because y divided by x is equal to 2.5, and that's the constant, the unit rate. Okay, there is no constant here, right? Like 4 divided by 1 is 4, 6 divided by 2 is 3, so there's no constant, so no constant for team B. Okay, and explain how you know distance for the other team is not proportional to time. Oh, oopsie, sorry. That's where that goes, okay? And then, sadly, the other questions are on the back, so I'm going to do some flipping. At what distance in the race would it be better to be on team B than team A? So for this question, better meaning probably covering more distance. I feel like if it's a race, that's what better would mean if you're defining it. So like at 1 hour, team B is further. That's great. At 2 hours, team B is further, right? 3 hours, team B is still further. At 4 hours, it's the same thing. It's exactly the same. So you could say like if the race, this is the cutoff time right here, like if the race was less than 10 miles, then probably team B would be what you want to be on because they cover more ground in less time. Okay, so let's write that. If the race is less than 10 miles, team B would cover more miles in less time, if that makes sense. If you find a better way to say that, great. If the members on each team walked for 10 hours, how far would each member walk on each team? So we're looking at 10 hours. So you can go up from there like 7, 8, 9, 10, and you could build on it. That might be easier here, right? Because that would be 14, 16, 18, 20, 22. So team B would be 22. And team A, for 10 hours, you already have 5 hours, so you can just double it. You can do that because we have a constant rate. So 10 hours would be 12.5 times 2, which is 25 miles. So you can see team A is better off if the race is longer. And will there always be a winning team no matter what the length of the course? No, right? No, because who won here, right? So if the course is 10 miles, it's a tie. If the course is 10 miles, it is a tie. If the course, sorry, if kind of got a little blurry. If the race is 12 miles long, which team should you choose to be on if you wish to win? These are getting a little tedious, right? If it's 12 miles, most likely you, right, this is where it changes. So after this 4 hours and 10 miles, you start to be faster on team A than team B, right? Under 10 miles, it would be the opposite, but over 10 miles, this would be faster because you would be covering more distance in less time. Okay, so we can write that there. Team A would finish in 4.8 hours, and we could get that by using our 2.5 miles per hour to figure out that. Finish in 4.8. I don't think you need to be that specific. Hours compared to team B in 5 hours. And how much sooner would you finish on that team compared to the other team? It would be 5 minus 4.8 would be 0.2 hours. And 0.2 is a fifth, right? So if an hour is 60 minutes, this is a kind of a challenging question. If an hour is 60 minutes, and if this is a fifth of an hour, right? Because that's 2/10, which is 1/5, right? That's 2/10, that's 1/5 of an hour. Divide this by 5. 60 divided by 5 is 12 minutes. So 12 minutes faster on team A than team B. Okay, and you don't have to be that specific. You could use 0.2 hours faster on team A than team B is fine, just by subtracting. That's just using fractions for good. All right, so your exercises are doing similar things as that example. I'm gonna stop this video and create a new one so it doesn't take forever to upload. The new one will have the solutions, and I'll go over the solutions with you. All right.